All right, so I'm going to explain to you the Cauchy-Euler equidimensional equation. Okay, equidimensional equation. So this is a second order homogeneous Cauchy-Euler. So the second order homogeneous. So second order homogeneous Cauchy-Euler equidimensional equation has the form at squared y prime. The generalized form cy prime plus cy is equal to 0. And where a, b, c are constants, and particularly a is not equal to 0. So to solve this, so solution, to write a general solution, what you have to do is to make an assumption of t is equal to m, and then solve for m. So if you have y is equal to, so let me call this one here equation A. Okay. So if you have y is equal to t is equal to m, t to the power m, then you can just find the derivative, the first derivative of this equation, the first derivative of such an equation, y prime is equal to m t to the power m minus 1. And then the second derivative is y prime, which is m minus 1 t m minus 2. Okay, so once you have these derivatives, which I'll call here b, then the next step that you do, the next step is to substitute b into a. Okay, so if you substitute b into a, then we're going to have an equation of this form, is a c to the power 2, and then y prime is nothing but m into bracket m minus 1 c m minus 2 plus b c m minus 1 plus c m is equal to 0. And then when you have that, then of course the next step is to write it as a m minus 1, and then this is t to the power 2 here, there's t to the power 2 here, there's m minus 2 here. So if you add it together, then you have t to the power m. Then you have plus b m, and then here too you have 1 here, and then m plus 1 here. If you add it together, you get this, and then you get that is equal to 0. Okay, so once you have that, then you just have to factorize your tm out. So you have a m minus 1 plus b m plus c is equal to 0. And then you can write it again as a m squared minus a m plus bm plus c is equal to 0. Then you can factorize it. You can write it as a m squared plus b minus a m plus c is equal to 0. Is equal to 0. Then you can solve a quadratic equation. So to solve a quadratic equation, we know that we know that for the quadratic equation, we can talk about the roots. So one, we can have real distinct roots. Then if you have real distinct roots, then our solution, our general solution will be nothing but c1 c to the power m1 and then plus c2 c to the power m2. Then we can also have repeated roots, okay? Repeated roots. So if you have repeated roots, then our general solution is also nothing but c1 cm. Okay, since the roots are the same, m1, m2 are all the same. Then the next one you have c2, then you have cm of length c. Okay, c2 cm of length c. Then the third one, you have distinct conjugates, complex as well. And then in this case, you have the root as r plus or is plus or minus is. If you have r plus this, then the general solution in this case, you can write a general solution as c1 cr cos s ln c plus c2 cr sin s ln c. Okay, so now we will take an example. So let's take an example. So if you take an example, we say that give the general solution of the equation x squared y prime prime minus 3xy prime plus 3y is equal to 0. So solution here, you start with y, let y is equal to t to the power m. So since we have an x, maybe I should just choose this to be an x. Then y prime will be mx m minus 1. Y prime will be m minus 1 x m minus 2. Then this is b. Then what you do is you substitute b into a. You substitute b into a, then you have x squared m minus 1 x m minus 2 minus 3x x m minus 1 plus 3xm is equal to 0. Then you have m minus 1 of xm minus 3m xm plus 3xm is equal to 0. So we have m squared because all the m's will cancel out, this will cancel out. Then we have m squared minus 4m plus 3 is equal to 0. And then you have m is equal to 1, 3. So if you have that, then you write your solution y, which we said was xm. Now you write y is equal to x, and then m1 is 1, so it's enough. So maybe then we have y is equal to x, and now m2 is equal to 3. So our general solution will then be written as c1 of x plus c2 of x to the power 3. And this would be our general solution. So we'll take another example. So example 2. Example 2, find again the general solution, okay, for the equidimensional equation which is valid in the domain x greater than 0. So which is given by x squared y prime prime minus 3xy prime plus 4y is equal to 0. And let's call this as A. So solution, let y be x to the power m, y prime be m, xm minus 1, y prime prime be m, m minus 1, xm minus 2. Okay, then you make your substitution, m minus 1, x m minus 2 minus 3x m xm minus 1 plus 4xm is equal to 0. Then you have 3m x to the power m plus 4x to the power x equal to 0. And with that, the same procedure, now you have m squared minus 4m plus 4 is equal to 0, and m is 2 and 2. And we call this the repeated root. So it's a repeated root. We said the roots are repeated in this case. So when we have repeated roots, then we know what we do. If we have repeated roots, then we say that our general solution. So what you can say is that our general solution is c1x to the power 2 plus c2x to the power 2 then x. And that is our general solution for the case of a repeated root as an example. Okay, so we'll give a third example. So, but for the third example, we said the third example is the case of the complex roots. And for that, we said if you have a complex root, then R, we can write it as alpha plus I beta, or I plus or minus usually it's alpha plus or minus I beta. And then in that case, we also make, we said let's C be written as E ln T. So in that case, we can write T, if we say T, then we say alpha plus or minus I beta. We can write it as T alpha and then dot T plus or minus I beta. And this will be nothing but T alpha E plus or minus I beta in T. And then if we use the Euler's formula, okay, if we apply Euler's formula, then we can write this as T alpha into bracket cos beta in T plus or minus I, and you have sine beta in T as well. Then in that case, if you write it out, so T alpha cos to bracket beta in T plus or minus I T alpha sine beta in T. Example. Example, if we have to find the solution, if we have to find a general solution, so example, find general solution for, we have T squared y prime prime plus 5 cy prime plus 5y is equal to 0. Then your solution is nothing but you let y equal to, we know how we write it usually, Cm, and then y prime is equal to m Cm minus 1, then y prime is equal to m minus 1 Cm minus 2. This is B, this is A. Then you can make substitutions. So you have m minus 1 and c squared m minus 1 Cm minus 2. Then you have plus 5 Cm minus 1 plus 5 Cm is equal to 0. If you expand, then you have m minus 1 Cm plus 5 Cm plus 5 Cm is equal to 0. And then can rationalize that and get m squared plus 4m plus 5 is equal to 0. And when you solve for m, you will get minus 2 plus or minus I. So your general solution then is, when you do that, then finally you have C1 T minus 2 plus I, then you have C2 T minus 2 minus I. And then if you expand using the Euler's formula, then you come to C1 T minus 2 cos ln T, and then you have C2 T minus 2 sine t. So this becomes the general solution for such a problem for the complex when you have a complex root.